All right, let's talk about something we all use every single day, but probably never give a second thought to: the number zero. I mean, it's everywhere, right? In our bank accounts, on thermometers, kicking off every countdown. But what is it actually? Let's dive in and try to unravel the mystery of nothing.
And that really is the question that gets the whole ball rolling. Is zero a real number, or is it just, well, nothing? On the surface, it sounds like such a simple, maybe even a silly question. But as we're about to find out, this very question has stumped some of the greatest minds for centuries. Okay, here's where things start to get a little weird. Look at the basket on the left. That's easy. The number 3 stands for 3 actual apples. We can see, we can count, we can touch. But the basket on the right, the 0 there represents an absence. It's a number for something that isn't even there. And that simple little fact creates this really fascinating paradox.
And that right there is what we can call the zero paradox. It's got this strange dual personality. On one hand, zero totally acts like a legitimate number. It follows all the rules of math. But on the other hand, it represents the very idea of non-being, of nothingness. How can it be both? From a purely mathematical point of view, it's not even a debate. Zero is a number, full stop. You can add it, you can subtract it, and you get perfectly logical answers. Think of it this way: 1 plus 0 equals 1. That's a valid equation. But 1 plus, say, not a number, that would just crash the system, give you an error. So mathematically, it's solid. But that's only half the story. This quote from the philosopher Neil Barton just nails the other side of the problem. We can have a real-world experience of two things or three things. But how in the world do you experience zero things? How can you get your head around a number that, by its very definition, means there's nothing there to experience? And this whole problem of experiencing nothing, it isn't some new age philosophical thought experiment. Actually, it's the main reason that zero was such a late bloomer in human history.
It's absolutely staggering when you think about how recent the idea of zero actually is. For thousands and thousands of years, civilizations were building pyramids and creating complex societies, all without a formal number for nothing. It popped up as a placeholder here and there, like in Babylonian math, but it wasn't until the 7th century in India that it was finally treated like a real number you could do calculations with. That huge delay just goes to show how deeply counterintuitive this whole idea really was.
So, early on, people came up with these, well, they felt like workarounds. Some said, oh, it's just the starting point on a number line. Others tried to equate it with the empty set in set theory. But these answers always felt a little incomplete. They do a pretty good job of explaining what zero does inside a system, but they don't really get to the heart of what zero is, especially that unique connection it has to pure absence. So if those old ideas don't quite cut it, where does zero truly fit in? How can we build a better, more complete understanding? Well, the answer comes from a really surprising place. It's all about how our own brains are wired. The absolute key to this whole puzzle is a concept called absence perception. It turns out our brains have this incredible built-in ability, not just to see what's there, but to actively notice when something we expect to be there isn't. This isn't just some vague idea. It's a real cognitive function, and it's the secret to solving our paradox. A really great way to get your head around this is to think like a computer programmer. Imagine you're filling out a form. If it asks for your income and you type in $0, that is a specific, known value. It means you have a confirmed absence of income. But if you just leave that field blank, a computer sees that as null, an unknown, a missing value. See the difference? Zero is an unknown. It's a known nothing. So how do our brains actually see nothing? Well, according to what's called the mismatch model, it's a pretty cool 3-step process. First, your brain forms an expectation, like a mental template. Let's say you expect sandwiches in your picnic basket. Second, you look in the basket and your brain tries to match that template to reality. But it fails. There are no sandwiches. That failure, that mismatch, is the crucial third step. Your brain doesn't just get confused, it registers that mismatch as a concrete perception, the perception of an absence. You see the lack of sandwiches. And that right there, that's the huge aha moment. That little cognitive trick our brains do is what lets us treat nothing as if it were something. It's what turns zero from this abstract philosophical problem into something tangible that we can actually perceive. And here is the big insight, the key takeaway. Zero isn't the absence itself. Nope. It's the property of a collection that is empty. It's the name we give it. Just like threeness is the property of a basket that has 3 apples, zeroness is the property of a basket that has no apples. It's simply the label we created for that perceived absence.
And what's so incredibly powerful about this is how this one simple idea, perceived absence, just makes everything click into place. In counting, well, 0 apples is just the perceived absence of apples. In algebra, adding an absence of quantity, of course, doesn't change your original number. And in computing, it perfectly clarifies why a known absence 0 is totally different from an unknown value null. It all just works.
So once you start thinking about zero this way, as the property of a perceived absence, you can really start to see why it wears so many different hats. This one concept unlocks its role in so many completely different fields.
Let's just take algebra, for example. We all had to memorize that rule in school, right? Anything plus 0 is just itself. It's called the additive identity. But now, it's not just a rule, it makes perfect intuitive sense. Of course, adding an absence of something isn't going to change the original amount. It's not some arbitrary rule, it's a description of how reality actually works.
And we can actually see just how big of a mental leap this is by watching how kids learn about numbers. Research shows that children learn to say the word zero and connect it with nothing pretty early on. But the idea that 0 is a number that is actually smaller than 1, that understanding comes much, much later. It just confirms how tricky it is for our brains to fit this quantity of nothing into our mental number line. And that's really the incredible truth of it all. Giving nothing a name and a symbol wasn't just some neat mathematical trick. It was one of the most profound intellectual leaps in all of human history. Without it, there's no algebra, there's no calculus, and there's certainly no binary code that runs our entire digital world. The modern world is literally built on a foundation of nothing. So in the end, 0 is both a number and it's the representation of nothing. And it's not a paradox at all. It's a brilliant tool, a technology we invented by taking advantage of our brain's natural ability to see what isn't there. It truly is humanity's greatest, most powerful, and most important nothing. The story of 0 is just this powerful reminder that so many of the ideas we take for granted as obvious today were once completely revolutionary. And it really makes you wonder, doesn't it? What other obvious concepts are all around us, just waiting for their own invention? Thanks for digging into this with me.